Let me record. Okay, so what I want to do today is to discuss the application of derivatives for finding the extremum, meaning the maximum or minimum of a function over certain interval. Okay. So the lesson or the topic is basically locating absolute extremum. For instance, so what we are given, so the data is, we are given a function, for example, f of x is equal to minus x squared plus 3x minus 2, and a domain or interval. So that means x is between 1 to 3. So I want to find or locate the absolute maximum and absolute minimum. What I need to do is the following. I have first to compute the derivative of the function. So first step is to compute the derivative f prime. So what is f prime? F prime of x is equal to minus 2x plus 3. The second step is to find the values of x at which f prime is either 0 or doesn't exist. So second step, find the values of x at which f prime of x is 0 or f prime of x does not exist or is undefined. So here, f prime, of course, because f prime of x is minus 2x plus 3, it is defined for any x. So we don't have any values at which f prime doesn't exist. However, we have some x for which f prime would be 0. So I can solve f prime of x equal to 0. So that means minus 2x plus 3 equal to 0. So minus 2x plus 3 is 0 means x is 3 over 2 or 1.5, right? That's it. So the points at which f prime is 0 or doesn't exist are called critical points. So critical points are the points that either f prime doesn't exist or f prime is 0. So the second step is basically finding the critical points. So critical points are those points for which f prime is either 0 or doesn't exist. So you only have one critical point here for this problem. Once you got the critical point, then the third and the last step is to compare the value of f at critical points, which is here only 1 point, and the end points of the interval that we have, and the end points of the interval. So here, let me just rewrite the f of x is minus x squared plus 3x minus 2, and the end points, I mean the interval is 1, 2, 3. So we basically have to list critical points and the end points, which is 1 and 3 here. So I list all these points, x. What is the critical point? 3/2. I put 3/2. What are the end points? The end points of the interval is 1. One of them is 1, another is 3. And then I have to compute the value of f at those points. So what is f of 3/2? F of 3/2 is minus 3/2 squared plus 3 times 3/2 minus 2. If you compute it, you get what? Minus 9 over 4 plus 9 over 2, right? Minus 9 over 4 plus 9 over 2 minus 2, which would be 9 over 4 minus 2 minus 8 minus 9 is minus 17 over 4, if I'm right. Please check this. Is that right? Over 2. So you have, let me write it here, minus 9 over 4 plus 9 over 2 minus 9 over 4 plus 9 over 2 is 9 over 4. Oh, sorry, 9 over 4 minus 2, 9 over 4 minus 8 over 4 is 1 over 4. Okay. So f of 3 over 2 is 1 over 4. What is f of 1? F of 1 is minus 1 plus 3, which is 2 minus 2 is 0. And f of 3 is minus 9 plus 9 minus 2 is minus 2. That's it. Now we are done. We just have to compare these points. The biggest one is the maximum. The smallest one would be the minimum. So here, this point would be the maximum. This is the lowest value, which is the minimum. Okay. So again, let's look at the steps. First, compute f prime, the derivative. Find the critical points. Second step. Critical points are those points that f prime is 0 or doesn't exist. For this question, we only have one critical point at which f prime is 0, and that is 3 over 2. And then the third step is just list all the critical points plus the endpoints. Here we have 2 endpoints, 1 and 3, and compare the value of f at those points. The lowest one, the least one is the minimum. The greatest is the maximum. Okay, so x equal to 3/2 is the maximum point. Maximum point. What is the maximum value? 1 over 4 is the maximum value. I will tell you in a second what is the difference between maximum point and maximum value. And the other one, x equal to 3 is the minimum point, and y equal to -2 is a minimum value. Okay. So this question, if you want, I can also draw the function for you, the graph of this function. The graph of this function goes like this. On this interval, of course. Okay, so the value of the function at x equal to 3 is -2, and the value at x equal to 3/2 is 1/4. Okay. Now, what is maximum point? Maximum point is the x value at which you have maximum. So here, maximum point is basically x equal to 3/2 is maximum point. Maximum value, as it sounds, is just maximum value, the value, which is here, 1/4, right? Minimum point is the point at which minimum value happens, which is 3, and minimum value is -2. That means basically the coordinate of the maximum is 3/2 and 1/4, this point, and the coordinate of the minimum is 3 and -2. Okay. Now let's look at another example. F of x is equal to x squared minus 3 times x to the power 2/3 over 0 and 2. So the first step, step 1, is computing the derivative. So f prime of x is 2x minus 3 times 2/3 times x to the power 2/3 minus 1. What is 2/3 minus 1? Remember that the derivative of x to the power r, the derivative of x to the power r is r times x to the power r minus 1, right? So the derivative of x to the power 2/3 is 2/3 times x to the power -1/3. And you can also write this, if you just simplify, it's 2x, sorry, 2x minus 2, x to the power 1/3, you can write it as 2/x to the power 1/3. Or x to the power 1/3 is root 3x. So you can also write this as 2x minus 2 over the third root of x. Third root. That's f prime. Second step would be to find the critical points. So at what point f prime is 0? So let's do this. At what point f prime is 0? F prime 0 means 2x is equal to 2 over x to the power 1/3. So if x is not 0, then you can cross multiply, you get 2x times x to the power 1/3 would be equal to 2. That means x to the power 4/3 is equal to 1. So for what values of x? X to the power 4/3 is 1. So that means basically x to the power 4 is 1. Because if you take the third root of 1 is just 1. So x to the power 4 is 1. That means x is what? Either 1 or -1. But -1 is not in this interval. Because -1 is not between 0 and 2. So we only accept 1, which is in this interval from 0 to 2. Okay, so we have this x equal to 1. But don't forget, we might have points at which f prime is not defined or doesn't exist. So let's look at this function f prime. At what point f prime of x is undefined? For what values of x? Something that is not in the domain of f prime. Look at this quotient, the fraction. 2 over third root of x. This guy is not defined or doesn't exist when x equal to 0. So x equal to 0 is also a critical point. So the critical points are x equal to 0 and x equal to 1. These are the critical points. And there is a coincidence. Here you have a coincidence, and that is one of the critical points is also an end point of this interval, because 0 is an end point. This is just a coincidence. Okay, and the last part is just list all the critical points and end points and to compare them. So let me just copy the function, the original function. F of x is x squared minus 3x to the power 2/3. And the interval is 0, 2. So I just list all the critical points and the endpoints, and I compute the value of f at those points. So the critical points are 0, 1. So you have 0, 1, and the endpoints are 0 and 2. So you just have to add 2. Okay, now what is f of 0? F of 0, x squared minus 3 times x to the power 2 over 3 is just 0. F of 1 is also 0, right? How about f of 2? Oh, f of 1 is not 0, sorry. 1 minus 3, which is minus 2. And f of 2, what is f of 2? So you have 2 squared minus 3 times root 3 of 4. So f of 2, let me write it here. F of 2 is 4 minus 3 times root 3 of 4. So with your calculator, can you compute root 3 of 4? What did you compute? The root 3 of 4 or the whole thing?
1.58.
1.5 root 3 of 4. So now can you compute this expression? 4 minus 3 times root 3 of 4.
Negative 0.76.
Negative 0.76. Perfect.
You wrote 6, 7.
Oh, 6, 7.
7, 6.
Yeah. Okay. Very good. So now you have to compare these values. The smallest is the minimum, which is of course this guy, and the biggest, the largest is the maximum. Here is this guy. It's a good exercise. Maybe here I just pause a little bit, and let's try together draw the graph of this guy. It's a good exercise. And you guys that are online, please try to draw the graph of this function. Okay, so in the last two examples, the interval that I gave you was finite, like x between 0 and 2. It's a finite interval. Sometimes the interval is not finite. For instance, let me give you an example. So f of x is x squared e to the power minus x squared, my favorite example. And the interval is from 0 to infinity. So here, one endpoint is infinite, but you could also have the two endpoints infinite. Okay. So again, you have to find it's the same thing. no matter what interval is, you have to compute the derivative anyway. So f prime, and I will tell you at the end what is the difference when you have an infinite interval. So f prime, let's compute this. So it's a product. So it's 2x times e to the power minus x squared. And then what is the derivative of e to the power minus x squared? The derivative of e to the minus x squared is minus 2x e to the minus x squared. So you have plus x squared times minus 2x times e to the power minus x squared. Which is equal to, if you factorize 2x e to the power minus x squared, you get 1 minus x squared. That is f prime. Now, the question is, what are the critical points? The critical points are the points at which f prime is 0 or f prime is not defined. So here, for what point or for what values of f prime is 0? So x equal to 0 or x equal to 1 or x equal to minus 1. Because you can have x equal to 0 when x is 0, f prime is 0. Or you can have 1 minus x squared be 0. That means x is either 1 or minus 1. And the reason is e to the power something is always positive, is not 0. Okay? So those are zeros of the derivative, zeros of f prime. You have 3 zeros. X equal to 0, x equal to 1, x equal to minus 1. But we don't have any point at which f prime doesn't exist, because f prime does exist for every point, for every x. Okay, so these are the only critical points. Now remember that the next and the last step is to list all the critical points plus the endpoints and find the value of f, the function, at those points. Here, one of the endpoints is plus infinity. So the difference is here you have to compute a limit of this function when x approaches infinity. So for this point, when x is plus infinity, what is the limit of this function? X goes to infinity. So it's limit of x squared e to the power minus x squared, x goes to infinity. And remember that e to the minus something, you can write it as 1 over e to the plus x squared. And I told you that exponential grows much more fast than polynomial. So e to the infinity is much bigger than infinity or infinity squared. Okay, so that means here the denominator grows very, very faster than the numerator. So this limit is 0. For example, for just your intuition, compare 100 squared and e to the power 100, like 2 to the power 100. What is the value of 2 to the power 100? Can you tell me what is 2 to the power 100? We know that 2 to the power 10 is about 1000, right? So 2 to the power 100 is 2 to the power 10 to the power 10. So it's 1000 to the power 10. So there are lots of zeros, of course, right? So you have 30 zeros. But 100 square does only have 4 zeros. But 2 to the power 100 has 30 zeros. It's not comparable. So this limit is 0. Is that clear what I said? Okay, that's it. So for whenever you have an infinity, you just compute the limit of the function at infinity, and then at the end you compare the values. You make a table. You put the critical points and the endpoints here. You have 0. The critical points, I only write 0 and 1 because -1 is not in this interval. So you have only 0 and 1. And the endpoints, you just have infinite. And 0, I already wrote it. So f of x, what is f of 0? F of 0 is 0. What is f of 1? Is 1 times e to the power -1, which is 1 over e. And f of infinity, as I just said, is 0. So that means 0 is the minimum. 1 over e is the max. Okay? So now I want you to go to the website and look at chapter 4.3. Chapter 4.3. Do these exercises at 4.3. $113. 116, 117. 123, 126, 127. Again. Okay. So this topic is optimization problems. For instance, here is an example from the textbook. You want to make a box. So you have like a piece of paper, like a rectangle. And you want to make a box out of this piece of paper. How you want to do it? You want to make a box with whose top is open. And how you do it? You just cut 4 squares from the corners. You cut the squares. I mean, you cut the corners like 4 squares. And then you fold up the rest of this paper, the sides, and you get a box, right? But the question is how to cut out these corners. And imagine these are squares. So what is the size of the total size? You have one side 24 inch. So this is 20. Oh, sorry. This side is 24 inch, and the larger side is 36 inch. So now the question is, for what values of x? X is the size of the square. The volume of the box that you make would be maximized. So would have the maximum volume. So that means first you have to find the volume of the entire box in terms of x. So once you fold this paper, you fold it up, what would be the volume of the box? So when you fold it, once you cut out the corners, so you get something like this. Let me draw it. Yeah.
It's just down the hall.
Yeah, it's down the hall. You're right. So once you fold it, one side, so what is the height of this box? The height would be x, right? So one side is 36 minus 2x. The other side would be 24 minus 2x. Is that clear? Now, what is the volume of this? The top is open, but that's okay. The top of the box is open. But what is the volume of this box? What is the volume of this box? The volume V is just x times 24 minus 2x times 36 minus 2x, right? And here we have to be careful because x is something between 0 and x cannot be greater than 12 because 2x is at most 24. It cannot be greater than. So x is less than 12 and greater. So basically, you see you have a function v, a function of x, and an interval. So we just discussed this type of problems. You're given a function on certain interval, you want to find its maximum. But here we just need the maximum. So let's do it. So we have to take several steps. One is to find the derivative, then critical points, then compare the critical points with endpoints, and done. So let me rewrite V. So V of x is x times 24 minus 2x times 32 minus 2x. And if you wish, you can simplify this because 24 minus 2x is 2 times 12 minus x. 36 minus 2x, this guy is 2 times 18 minus x. And this is just 2 times 12 minus x. If you multiply these numbers, you get v is 4x times 12 minus x times 18 minus x. And just for the sake of computing derivative, it's easier if you first multiply the brackets first. So what is 12 minus x times 18 minus x? So 12 minus x times 18 minus x is x squared minus 30x plus 12 times 18. What is 12 times 18? Can you use your calculators? 216. This or 216?
216.
Okay. Very good. So v of x is just 4 times x cubed minus 30x squared plus 216x. This is v of x. And again, x is something between 0 and 12. So then the next step is to compute the derivative. V prime would be 4 times 3x squared minus 60x plus 216. Now find the critical points. So that means the points at which v prime is 0 or doesn't exist. We don't have any point for which v prime doesn't exist, but we have some points, we might have some points at which v prime is 0. So at what point v prime is 0? So what is v prime? V prime is 4 times this. So if you factor out 3, so you get v prime. Let me write it again here. V prime is 12 times x squared minus 20x. What is 216 divided by 3? 72. Now, can you find the points at which v prime is 0? That means x squared minus 20x plus 72 must be 0. So you just solve, you have to solve for x. It's a quadratic equation. Can you do this? So give me 2 values for x. X is I know this has to be 10 because 20 over 2 is 10 plus what? 2 times the square root 7. And the other root is x equal to 10 minus 2 times the square root of 7. But 10 plus 2 root 7 is greater than 12. 10 plus 2 root 7 is greater than 12. So we cannot accept this one because we are looking for x between 0 to 12. So this is not acceptable. But this one is acceptable. This is between 0 and 12. 10 minus 2 root 7. What is 10 minus 2 root 7? Approximately. Hmm? 10 minus 2 root 7. It should be something about 4 or 5. Hmm? 4.7. So this is the only critical point in this interval. This is important. The interval, the original interval is important because we have another critical point, which is not in that interval. Okay, so now you have to list all these critical points and the end points, like x equal to 0, x equal to 12, and x equal to this point. So you have 3 values basically for x. And you have to compute the value of f, or here, sorry, it's v, because the name of our function is v. So this is v of x. So we have 0, 4.7, and 12. But v of x is 0 when x is 0 or 12. These 2 values are simple. So of course, whatever the value of x is at 4.7, that would be the maximum. I mean, it must be the maximum. So what is, and can you compute v of x when x is 4.7. V of x is given. It's x times 24 minus 2x times 36 minus 2x. It must be something 1825 inch cube, because we are talking about volume. The scale for the volume is like meter cube or inch cube, depending on what is the measure for length. Okay. Is that clear, everyone? Okay, so what is the setting? What is the problem? So you see there is an island that is 2 miles away from the shore. You see in this picture. And there is a visitor in a cab whose distance with the closest point to the island is 6 miles. So imagine that the visitor wants to go to the island, but they can either swim or run, or, I mean, you have to eventually swim, but the problem is which path you take. Do you directly swim from your cab to the island, or you run some distance and then swim to the island? Because of course, if you swim directly, it's the shortest path, but the speed of your swimming is slower than the speed of your running. So how to go to the island in order to minimize the time that you spend, okay? And here you have the speed of running and the speed of swimming. So we can compute the time for each part, for swimming part and the running part. And if you put this together, you can compute the minimum path, okay? So you need, so this is just a real world problem. There is no function, nothing. But here you have to first compute the time. T is your function that you want to minimize. And it's a function of x. What is x here? Okay, we can assume that you run x miles from the cab towards the island on the shore. You run it first, and then you swim. After x miles running, you swim towards the island, okay? So what is the time that you spend for running? So the time of running, you see here, T of running is D for running, is the distance, divided by R. R is the speed or rate. Rate of running means the speed, okay? So here in this problem, a speed of running is what? Let me see. 8 miles per hour. And speed of swimming is 3 miles per hour. Okay, so the time that you spend for running is x, because we don't know what's the value of x, divided by 8. This the velocity, the speed. And the time for swimming now, what is the time for swimming? So you have to compute the distance that you swim. The distance that you swim, if you use the Pythagorean theorem, it would be what? Square root of 4 minus x squared plus 4, right? I mean, here the value of y in this picture is square root of 4 plus 6 minus x squared. Is that clear? Like here, you see, y is square root of 6 minus x squared plus 4. So, and you have the time for swimming. The total time is the time for running plus the time for swimming. And that is your function, basically, that we computed from the real world problem. This is t, the function is a function of x. You want to find its minimum. And be careful, x must be between 0 and 6. So the interval is also given. The interval is from 0 to 6. And t is given, the function. I mean, we computed t. So you just need to compute the derivative, t prime. Then you find the critical points. And then at the end, so what are the critical points? And at the end, you compare these points. So the critical points are basically the points at which either t prime is 0 or t prime does not exist. So t prime 0 means x is these two values, 6 plus minus 6 over root 55. So one of them is not in the domain. 6 plus 6 over 55, root 55, is not in the domain because it's greater than 6. So we are looking at the interval 0 to 6. So the only critical point is 6 minus 6 over root 55. And you also have the endpoint. What are the endpoint? One endpoint is 0, another endpoint is 6. So you can compute the t, corresponding t, for each of these points, the only critical point and two endpoints. If you compare them, you can see from this comparison that 6 minus 6 over root 55 is the minimum point. You see? You have three values, t of 0, t of 6, and t of 6 minus 6 over root 55. So the smallest value is this one, the last one. So that means the best path to reach the island is to first run a little bit, like this distance, 6 minus 6 over root 55, and then swim. Okay? Is that clear? Okay? Kenny, Betty, Cynthia, is that clear for you?
Yes, I think it's clear.
Okay, so that is the end of optimization problem. I mean, I can maybe give you more examples, but they're all basically the same logic. Here are some exercises that you can do. So I want you first, look at these examples first from the textbook, like example 4.36 and 4.37. Just read these two examples and there is solution. After you read these two examples, then you go to the end of this chapter, the exercises, and do question 315, 316, 317, so 15, 16, 17, and 21, 22. So again, 315, 16, 17, 321, and 322. And you can ask me if you have any questions. I'm here. And I want you to also send me your assignments. Assignment 2 and assignment 3, if you haven't done so.